Okay, so we're going to be doing arithmetic sequences. Arithmetic sequences and partial sums. What this really is arithmetic series. It looks kind of like a line in terms of like the equation. It's like a line. It just adds the same number over and over again, or subtracts the same number over and over again. And then the hard part is you have to figure out what the starting number is. Okay? So there's two formulas for this. Here's the first one. So it just says that a sub n is equal to the first term plus n minus 1 and whatever the difference is. The difference could be it's going up 3 or it's going down 2. That's what the difference represents. And then you just plug it in and then bam, you get your a sub n. Simple formula, right? I don't like that formula. Not a fan of it. Also, this is what I do. A sub n equals a sub 0 plus, I'll do d times n. That's what I do. The problem is we don't have an a sub 0 ever. So we just had to figure it out what it is. It's not that hard though. So for this first one right here, let's start with d. How much am I increasing by? 3 every single time, correct? So that's my d value. So d is 3. So that's my first term is 5. If there was a term before it, what would it be? So that's my a sub 0. It's 2. So a sub n is equal to 2 plus 3n. Bam. Done. Okay. You could use this formula and get the exact same thing, but you would need to distribute it and do some math. This one, I just tell you, use your brain. What's the previous term? What would it be? Okay. So what's the difference? What would the previous term be? Bam. Plug it in. Okay, let's actually get more difficult here for number 2. So now we have fractions, and this is like super hard to tell what's going on. What can I do to like maybe fix this so it doesn't look so super hard? Okay, what's a good common denominator? 6. So let's put all these over 6. So what's 1? 6 over 6. 7 over 6. What would this one be? 8 over 6. I think I see what's going on. What's going on? 9 over 6. 10 over 6. And you couldn't tell this unless you... Well, I'm sure some of you are like smart enough to figure it out. But me, I can't figure this out unless we do that. So, what's my d value? How much am I increasing or decreasing by? 1/6. And if I go backwards one step, what would my previous term be? 5/6. So, a sub n is equal to? And that's it. Now, could you use this formula? That'd really be a bummer. Because we got fractions and stuff. So, I think we're just better off doing what we're doing. Okay, so for the other formula, a sub 1 here is 1 plus n minus 1, and then the difference is 1/6. But then you need to distribute, so it'd be 1 plus... Yes. Because it has to be simplified. Well, you know what? You're not using that formula. Right, and then if you simplify this, you get the same answer down here. Alright. Let's find the nth term. So, find the formula for the nth term whose common difference is 5 and first term is -1. So, so I know some values. So, what's the common difference, which is d? 5. And it says the first term is -1. Okay. Oh, this is kind of nice because they gave us the first term. What would the 0 term be? So actually, let's go with this. Let's write this out a little bit. What would this sequence be? So the first one is -1, and then the next one is 4, and then it's... And you get the idea, right? Okay, so what's a sub n? So does that help by writing it out a little bit? Sometimes they won't give us the numbers like that. But this one was kind of easy because they gave us the first term. If they give us like the third term or the fourth term, we gotta do a little bit of work. Just a little bit. Want to try 4 on your own? It's like the same exact problem. Sure you all said? Okay, go do it. I'm glad you think that. I don't know, maybe. Alright, so what do we get for this one? D is 3, A sub 1 is 2, so we're going to get 2, 5, 8, you get the idea. And then we're going to get A sub n to equal... Okay, can I give you a harder problem? To make you learn? I'm just doing it below. So, I'll call this like 4b. So let's have D equal -3. Oh. And A sub 12 is equal to... I don't know, let's make it 8. Find A sub n. Okay? So I want to walk you through a problem like this, because we actually need to do this in a couple problems coming ahead. But I'd rather just break this one down like this, and then you kind of see. Okay, so what do I know so far? So I'm going to use, this is kind of like my helper information. I'm going to use that in a little bit. Okay? What can I write so far for my formula? So A sub n is equal to A sub 0 minus 3n. Do you agree with this statement so far? Okay. This says when n is equal to 12, my final number is 8. Right? So A sub 12 is equal to A sub 0 minus 3 times 12. I'm just plugging in information that I know. I'm plugging in a 12 because I know 12. So what is A sub 12? It's 8. So it's A sub 0 minus 36. How do you find A sub 0? Add 36. And what do you get? Equals 44. So now I know everything, right? A sub n is equal to 44 minus 3n. Good. A little bit harder. A little bit more fun. I don't want to bore you here. I'm going to skip 5. We just did a problem like that. Not a big deal. Skipping it. Okay. Let's go and do 6. Zoom out a little bit more so you can see everything. Can you see that back there? Sure? Okay, I'll take that. So the fourth term is 20. So A sub 4 equals 20. 13th term equals 65. Write the first 5 terms. So pretty much I need a sub n. I don't have that right now. Oh. I'm talking to the notes. Wait, thank you. It's a counselor request. She's in trouble. They're gonna talk about college. I don't know. Maybe. Why not? Every time someone has a counselor, it's usually like a college. Not all the time. Most of the time. Okay. Alright, moving on. So, what the heck do I need here? I need a lot. I need a sub 0 and I need D. So I need those two things. How in the world can I find any of these? Well, I can't find a sub 0 unless I know D. How can I find D? So this is like a linear equation, right? I already mentioned that. It's like super similar to a linear equation, and D represents the slope. So you're gonna do, yeah, like the change. Yeah, we're gonna do like the change in what's going on here. So this is gonna be a sub 13 minus a sub 4 all over 13 minus 4. You're so SMRT. So a sub 13 is 65 minus 20 all over 9, and we get 5. So now how do I find a sub 0? Well, I have this information so far. Does it matter which one I plug in? Does not matter. I favor smaller numbers. Just the kind of guy I am. So I'm going to plug in a 4. When I plug in a 4, I'm going to get 20 equals a sub 0 plus 5 times 4, which is 20. So what is a sub 0? It's 0. So my a sub n is going to be 5n. Did I answer my question? No. What are my first 5? So what's a sub 1? 5. A sub 2. A sub 3. A sub 4. Hey, we have that. 20. A sub 5. 25. Five, comma 10, comma 15, comma 20, comma 25. Dot dot dot. Yep, good enough for me. Try 7. Same problem with different numbers. Try 7. See how you do. So quiet. I don't know how I like this. How we doing? Yeah, I can't do math. Just trying to do paying attention. Good. One of you is. We good here? I see some people looking like, huh? So I just want to make sure I answer any of your questions. Anybody have a question? You can have a question. We good up here? Yeah, we are. No? Yeah, no. Hey, you chose that seat. How are you liking the seating arrangements? Better? Okay. No one cares? What's that? You're okay with 60% of it? Alright, we just need to get through the words on this one. This one's like easier than the ones we're just doing. You just need to understand what the words. So let's go through it. So find the 10th term of an arithmetic series that begins with 8 and 20. What does that mean? It's worded like really poorly. I'm just gonna be honest with you. It begins with what number? And then a. And it says it's arithmetic, so that means it has to be increasing or decreasing. So it's by increasing by how much? So it's like this, right? So a sub n is equal to, what would the number before 8 be? Negative 4 plus 12n. Okay, and it wants what? A sub 10. What's 12 times 10? Very good. 120 minus 4. This is so exciting. Yes. Okay, so I'm going to give you a recursive formula now, and I'm going to make you write it explicit. So here's the recursive formula. So the first term is a 6. The next term is a, take the previous term and add 5. So you're going to get 6. Because it says A1 is 6. Now this means the previous term. So to find A sub 2, you got to plug in a 1 for K. I hate this. It really should look like this, by the way. This annoys the heck out of me. I've never seen a textbook write it like this. It should always look like this. This makes more sense. That means the previous term plus 5. It makes more sense to me. I see some heads bobbing, so either that's a sympathy head bob or you understand it. I'll take either one. So this just means the previous term, A sub K minus 1 plus 5. So the next term is going to be the previous term plus 5, which is 11. The next one is 16, and this is arithmetic. You agree? It's increasing by how much each time? So what's the first number going to be? Well, not the first, the A sub 0 number. So it's going to be 1 plus 5n. Now the note keys, I think they have the order different. They have like 5n plus 1. I don't care. I just don't care enough. It doesn't bother me one way or another. Okay, so in this formula, There are 4 things in this formula. You agree? I'll zoom in so you can see it better. I'm just going back to the front real quick. You don't need to. You can just look. There are 4 things in this formula. A sub n, A sub 0, D, and n. We've done problems where we need to find A sub n. Yeah? We've done problems where we need to find A sub 0. Yeah? We've done problems where we got to find D. Yeah? Now we're going to start to do problems where you have to find the n value. So it's going to like tell you like, whoa, well, the numbers start here and then end there. How many numbers are there? And then you need to work with them. Okay? Pretty much, here comes the sum of a finite sequence. And I'll explain this to you. And the formula is written weird. I write it differently. I just rewrite it differently. I don't really care. Because when you look at this formula, it's like, okay, I just got to memorize that. Right? I don't memorize anything. I just understand it. I hate memorizing. So, what you're going to do here is you're going to take the first term and the last term and divide by 2. That gives you the average. It's giving you the average of every term. You take the average of every term and multiply it by how many terms there are. And you get the sum. So, like, if I have like 1 and 2 and 3 and 4, you get the idea, and then I end at 10. What's the first term and the last term? Ah! So the first term is 1, and let's say I need to add all these up. Okay, so I'm going to do 1 plus 2 plus 3 plus 4 plus whatever. What's the average? 1 plus 10 is divided by 2. So it's 5.5. That's the average. Because if I do the next ones, if I do like 2 plus 9, average is to be 5.5. And I just keep doing that as I keep getting closer and closer to the middle. But how many terms are there? So each term averages at 5.5. How many of them are there? There's 10 of them. 55. Does that make sense? Okay, so now let's go ahead and do it for slightly weirder problems. So find the sum of integers from 1 to 35. So the exact same problem that I just did, but instead of 10, we stop at 35. So what is the first number? It's 1. What is the last number? 35. And how many numbers are there? There's 35. So the sum of 35, when n is 35, is going to be, well, 35 times the average, which is 1 plus 35 all over 2. Don't forget, you have a calculator, so you don't have to be like, oh, I can't do math. $630? Did you just say yes, just not knowing what it is?
No, I already did it.
Am I going too slow?
No.
Alright. Alright, that's it.
Oh,
How can this get harder?
what does that even mean?
Find the sum of 2 digits of multiples of 3.
What does that even mean?
Find the sum of the 2 digits.
Okay, so what are the digits?
12, 16, all the way up to 21.
So starting at 12, so we'll write the sequence down as 12, 15, 18, 21, all the way until it needs to be 2 digits. So I can explain it for you. Daniel, that's brilliant. So I had no clue what they were talking about until you said that. Like, what are they talking about? So they want 2-digit numbers that are multiples of 3. What's the first 2-digit number that's a multiple of 3? 12. And then you keep going until you get to 99. Okay? So we need to figure out what the heck is going on here. So, how many numbers do I have? That's kind of important, because I can figure out the first and the last. That's not a big deal. How many numbers do I have? How do you figure that out?
Well, 99 is 30, or 33 times.
Well, let's do this. A sub n is equal to, increases by how much? Or sorry, what's the first number? Okay, sorry, the a sub 0 number. 9 plus 3n. Correct? So we need to figure out what the n value is for 99. So it's
30.
what's the n value for 99?
30.
So you plug in a 99. Yeah, we good so far? Some of us are catching it, some of us aren't. That's why I'm going slow. So this is your last term, right? We should know this part. All you're going to do is plug in the last term and solve for n. So subtract 9 divided by 3, you're going to get n is 30. So you have your first term. So you have 30. Your first term is 12. Your last term is all over 2. I highly suggest a calculator. 1665. The year 1665. This is an S. Stands for sum. What happened in the year 1665? Anybody know? The English. I have no clue. What? What's your question? Sorry, I skipped some work. Alright, let's go ahead and find the 150th sum of the arithmetic sequence. 5, 16. Okay. Let me know when you're ready. Alright. Number 12. Asking the same information, but only giving you different pieces. That's what's going on here for like these past couple problems. I'm just asking for the same information, just giving you different pieces of information. Good. So this one, what is it giving me? It gives me the 150th sum. So n's 150 of the series. Well, let's figure out that series. What is it? A sub n is equal to. What's my a sub 0? You're right, it's increasing by 11. Negative 6. Okay. So, I have my first number, which is 5. What's my last number? Plug in a 150. Here we go. Negative 6 plus 11 times 150. Oh, the year is 1644. What was in the year 1644? I have no clue. I cannot verify. See, I'm trying to integrate other subjects into math. After this, we'll write an essay. And then we'll make a hypothesis. And then we'll say that in Spanish. And we'll run around the building as we do that. While we're running, we're going to draw some pictures on the wall. You have to be singing while you're running. Am I missing anything? Oh, and then text somebody on your phone. That's technology. Alright. And then your school day can be over. We can do your whole school day in a matter of 5 minutes. You hit every subject. You go home. Call it a day. Oh, hey, I didn't answer anything yet. So the sum is equal to, what's n? 150. What's the first term? Plus 1644 all over 2. Now I just put the over 2 here. It doesn't matter where you put the over 2. I just put it here because I'm hoping that helps you understand what the heck is really going on here. Because I'm not all about memorization. I'm all about understandization. So when we use our handy dandy calculator, 1, 2, 3. 1, 2, 3. 6, 7, 5. And ooh, it's gotta hurt. Alright, so we're gonna do 2 plus 4 plus 6 plus 8 plus. Or is there an easier way? I'm totally lost. Help me. So, I just want you to find the sum. I don't feel like doing 2 plus 4 plus 6 plus 8 plus all the way up to when we get to 100. So all the way up to 200. What can we do? It changes by 2 each time.
So your a to the 0 will be -1, right? Because n is your a to the 1.
I like your thought process. I like your thought process.
I don't know.
We actually don't need to find what a sub n is. Like, we don't need to do like the whole formula, believe it or not, because this actually gives us everything we need. Because what's my first term? What's my last term, which is a sub 100? It's 200. How much am I increasing by? Or how many numbers are there? This is where it's kind of important to know that there are 100 of these terms. Don't say 99. Don't be like, oh, 100 minus 1. There's 99. You're neglecting the first term. Okay? So how many terms are there? There are 100. We have everything. So the sum is equal to, it's 100 of these, taking the average. The first, the last. Get an answer of I'm going at a speed of 0 right now. I couldn't slow down anymore. 10, 10, 0. Hey, I say things. You just deal with it. It's how I do things in the Weidenbauer house. Hey, can I give you like another problem? Like lots of fun problem? Here we go. We'll make this number 14. I want to make sure that we know what the heck is going on. So we're going to go from 43. Oh, that should probably be n equals in the bottom. 82. So from 43 to 82. What's my first term? What's my last term? Plug it in. 167. How many are there? How many terms are there?
Hey, can we slow down?
Yeah. 82 came from the problem. This is made up.
Oh, I thought that said 23.
Believe it or not, there is a seat like about 10 feet away from the board. No? Okay. Your choice.
N is 82, isn't it?
Yeah, subtract the top and the bottom and then add 1.
Subtract the top and the bottom and then add 1, is that what you said?
Yep. So how many terms are there?
39, 40.
40. What do we get? 5120? That's how I give my credit card numbers. I give them by 2 digits. So I was like, okay, it's 3, 2, 8, 6, and then it takes too long. 32, 86. It's not my number. None of those numbers are on my credit card.
Okay.
My real credit card number is...
What's great credit card?
Eh,